Hello everybody, this is Tonka Online Pre-Calc, Chapter 1, Lesson A on lines. Objectives are as follows. We're going to find the slope between 2 points, understand and be able to use those three forms for an equation of a line, understand and identify parallel and perpendicular lines based on their slopes as well as their graphs, and then we're going to do some application problems. So without any further delay, let's get started. All right, so let's get started with the idea of slope. Here you can see that I have point A designated by the coordinate x1, y1, and B with x2, y2. To find the slope between these 2 points, or any 2 points, what we want to do is take y2 minus y1 over x2 minus x1. In your algebra courses, you may have seen this as rise over run, or possibly change in y over change in x. Please be aware, as many students will mix this up and put these two, change in x over change in y, in the wrong place. Please don't do that. Obviously, that would make all of your answers wrong. So focus on change in y over change in x and keep that straight. We're going to have many formulas to work with this year. This is one of the easier ones, but just want to get started in the right path here. So when we find the slope of any line, slopes can be broken down into 4 possible orientations. The first one is a positive slope. A positive slope increases from left to right. A negative slope, which will decrease from left to right. A zero slope, which is a horizontal line. And an undefined slope. And an undefined slope is a vertical line. So I got slope guy here is a nice way to remember. Got a positive slope here for his right eyebrow. We got a negative slope for his left eyebrow. We got an undefined slope representing the nose, and we got a zero slope for the mouth. So just a way to remember those. So with that formula, let's go ahead and let's find the slope between these 3 pairs of coordinate pairs. I'm going to name all of the first coordinates x1, y1, and all of the second as x2, y2. So let's use our formula. So the slope of the first pairing, the slope between those 2 points would be y2 minus y1, which would be negative 10 minus a negative 5, and x2 minus x1. And it looks like when we do some calculations, we get a negative 5 over a positive 5. So the slope between these 2 points would be a negative 1. Okay, for the second example, we're going to take y2 minus y1. Seeing a slope of 0 coming over x2 minus x1. It looks like I will get 0 over 15, which of course we can write as 0. All right, likewise for the third, and in any example, as you're working through, if you want to pause the video, feel free, and go ahead and work through a problem, come back to see how your work compares. Looks like I get negative 19 over 0. And anytime you divide by a 0, most times, at least in this course, what's happening is you have a vertical line representation of some sort. So this slope is undefined. All right, so let's keep moving. Look at the next slide. All right, so let's get into our first equation for a line. It's called point slope form. And what point slope form looks like, you may have seen this in courses past, is it's going to look like this. Y minus y1 equals slope x minus x1. Okay, and that's built actually from this equation for slope y equals y2, or m equals y2 minus y1 over x2 minus x1. If you multiply both sides of this by x2 minus x1, you'll see that the x2 minus x1's on the right side reduce, and the x2 minus x1's on the left side get multiplied by m. So what you're left with is y2 minus y1 is equal to the slope times x2 minus x1, which we then generalize taking the 2 off of y2. And if we're given a point and we're given a slope, we can write the equation of a line. The point that we'd be given would be x1, y1, and the slope that we'd be given or have to find would be m. So let's use that equation in the following example to write the equation of a line in point-slope form given the information below. Then we're going to find g of -2 in both cases. So in part 1, g of x is linear and has a slope of -1/2. So we can take, get off of highlighter mode, Mr. Ludd. We can take this slope of -1/2 and the point 9, -4, and we can formulate a line. So I'm going to take y minus y1 and then the slope and x minus x1. I'm going to take 9 and -4, plug them in their respective locations. Therefore, I could say that y plus 4 is equal to -1/2 x minus 9. That is the equation of a line that has a slope of -1/2 and passes through 9, -4. Okay, so I'm going to solve for y. I'm going to distribute a -1/2. So y would equal -x/2 plus 9/2, and then I am subtracting 4 over. So this function y is -x/2, and 9/2 minus 4 is 1/2. Now in this particular example, we are calling this function g of x. So I'm going to change the notation from y in terms of x to g in terms of x. Okay, so what we've got here then is a function whose slope is -1/2 and passes through the point 9, -4. You could confirm that by plugging in 9 and -4, and you'd be good. Okay, so let's go ahead and let's find g of -2. So this is function notation, and what g of -2 is just the function with -2 plugged in. Okay, so x is going to be -2, and we're going to solve this and evaluate it. So -2, -2 is a +2. +2 over 2 is 1. 1 plus 1/2 will end up being +3/2. Awesome. Okay, now in number 2, or part 2 of this question, we're not given a slope. As you can see, I'm given g of 0 equals 11 and g of 5 equals 9. So it looks like I have to manufacture a slope. So my slope is going to be y2 minus y1, I almost did it to myself, over x2 minus x1. And you can pick these in either order, but it looks like my slope is going to be -2/5. Okay, and I can pick either of those 2 points. I'm going to choose to use 0, 11 for my point. 0 will make my function come out to be much nicer. And so using point slope form, what I've got is y minus y is equal to the slope times x minus x. Okay, so y will equal -2/5, 2/5 x plus 11. Notice that the 0 disappeared. It's not relevant. So g of x is equal to -2/5 x plus 11. Let's find g of -2. G of -2 will then be -2/5 times -2 plus 11. Notice how I'm working vertically here. I'm not going across the page from left to right with a string of equal signs. That is just a foul in math. Okay, 11 is equal to 55/5. I'm just getting a common denominator here. Therefore, g of -2 will be equal to 59/5. Okay, guys, I'm trying to model proper notation along the way, so pay attention to those details. Okay, here we go. Time for a little application in the area of finance. It says in 2009, a shoe company's net sales were 12.2 million, and in 2016, net sales were 13.3 million. Write a linear equation in point-slope form for net sales, S of t in terms of years t. Use this then to predict sales in 2020. So two things I need. I need a point and I need a slope. So let's start with how we're going to determine points and slopes. Well, I'm going to designate that 2009 is equal to t equals 0. Okay, that's representing t equals 0. And in 2016 then, 7 years later, t would equal 7. Therefore, S of 0, right, total net sales in year 0 was 12.2 million. You could write that as S of 0 equals 12.2 or 0 comma 12.2. Those are equivalent forms. Our other point will be S of 7 will equal 13.3, or you could write it as 7 comma 13.3 as an ordered pair. Okay, so this allows me then to find the slope. Now the slope will equal y2 minus y1 over x2 minus x1, or in this case, t2 minus t1. Okay, so I'm going to say, without reducing, I'm going to say the slope is 1.1 over 7. So it looks like $1.1 million per 7 years. Okay, now, in point-slope form, let's write out our equation here in blue, actually green, because it's all about the money in this case. So y, and I'll change this to s in a moment, but y minus y1, I'm going to fill that in a second, will equal slope, which is 1.1 over 7, x minus x1. Now I have a choice here. I can either use 0, 12.2, or 7, 13.3. I'm going to choose to use 0 for my x and 12.2 for my y value. Now, technically, I should have an s here and a t here, and I'm going to do that in just a moment. But just to keep the form the way that our equation is for point-slope form, I'm going to keep it that way for just a moment. Okay, so y would equal 1.1 x over 7 plus 12.2. Now I'm going to write this as now s of t, this is where I'm going to change my variables, is equal to 1.1 t over 7 plus 12.2. That would be an equation. Actually, both of these equations, this as well as this, would be acceptable. However, the top one would need to be in the form s and t, but this right here would be kind of your sweet spot for your linear function. Okay, so now it tells me, now that I have this linear equation, in terms of t, which is years, I can then find s of 2020. Now, don't make the mistake of plugging 2020 in. I don't want that. What I want is 11 years later. So this is 11 years later, not the year 2020 inputted. So we're going to take 1.1, we're going to multiply it by 11, divide it by 7, and add it to 12.2. Okay, we're going to plug in an 11 right here. If you don't have a graphing calculator, you need to find a way to either get one from a friend or purchase one from one of the big box stores. So per my calculator, what I'm getting is that S of 11, or the income in 2020, net sales, is equal to 13.928. I'm going out kind of ridiculously far here because I want to prepare you for what you're going to see later on in calculus if you decide to go there. Now, in calculus, what we'll do is you got two options. You can either truncate, which means you could write S of 11 would be equal to 13.928 at 3 decimal places, $1 million. Or you can round to 3 decimal places, which would be what would that be? $13.929 million. Either of those two would be acceptable, okay? Unless the problem specifically and explicitly states to the nearest whole number or changes the decimal value for you, you are always going to round to 3 decimal places. Okay, our second equation of a line is called slope-intercept form. Now, slope-intercept form has its advantages and disadvantages. The advantage of slope-intercept form is that b is the y-intercept, okay? And we can find that in a number of different ways. But what we're going to do is we're going to write an equation for a line in slope-intercept form out of the following. And we're going to determine slope and y-intercept for each of them, okay? So the first equation here, or the first line that we have in part 1 is already written in slope-intercept form. So it's very easy to find the slope and the y-intercept. So the slope in this case is exactly where m is located in the linear form. So the slope here is 2. The y-intercept, please don't make the mistake of saying the y-intercept is 5. It's not. The y-intercept is the coordinate or ordered pair 0, 5. Okay, in part 2, we see something very unique. Anytime you see x equals a number and there's no y present, if you were to graph this on your graphing calculator, what you would see is that at -7, you'd have a vertical line. Now, that was supposed to be on that spot, but I'm not perfect other than my haircut. So what you'll see here is that this is a vertical line. Therefore, its slope is undefined, and its y-intercept, well, where is it? It doesn't exist. Here's a symbol for it doesn't exist. Okay, does not exist. That's math language. It's emoji. It's whatever you guys want to call it. Okay, but the y-intercept doesn't exist because it'll never pass through the y-axis. Okay, now in part 3, it's this kind of unique. We don't have the equation of this line in slope-intercept form yet. So what we need to do is put it in that form, and then we can determine the slope and the y-intercept. So I'm going to distribute the 5 on the right side. That gives me 5x plus 30. I'm going to add 4 to both sides. Adding like terms, that gives me y equals 5x plus 34. Therefore, my slope is 5, and the y-intercept is the ordered pair 0, 34. Okay, this last form that you're going to see here is still a line. It's called general form or standard form. What I'm going to do is get every term away from y. I'm going to strip away the -2x. I'm going to divide by a -8 in a moment, and then we'll have it in slope-intercept form. So I'm going to add 2x to both sides. That gives me -8y is equal to 2x plus 40. And then I'm going to divide by a -8. That gives me reducing -x over 4 minus 5. Therefore, now I have what I want, which is -1/4 for the slope, and my y-intercept in this case ends up being 0, -5. Okay, so pay attention to signs as you do this. It's very easy to mess up the algebra in those. And honestly, easy points as long as you do a little bit of practice. All right, let's move to the next slide. Okay, so on this slide, I want to cover the 3 forms for the equation of a line, which we've talked about. Standard or general form, as you can see, is ax plus by is equal to c. Point slope, of course, we did a couple examples with that, as well as slope-intercept. So I'm going to write an equation for each of the lines below using any form from above. You could use slope-intercept quite easily here, seeing that we know what the y-intercepts are. Looks like they go through nice round numbers here. So I'm just going to, for this case, the blue line I'm going to do in slope-intercept form, and then the red line, I don't know, maybe we'll do standard form just for fun, okay? So let's do the blue line. Let's look at the blue line. It looks like it's y-intercept. Based on how this is scaled, the y-intercept would be 1, 0, 1. And the slope, let's see if I can designate a point here. I would call this 1 and 2 and 3 and up 1 and 2. So this would be the point 3 comma 2. Now the slope between those 2 points would be 2 minus 1 over 3 minus 0. So it looks like the slope would be 1/3. So if I know the y-intercept is 0, 1 and the slope is 1/3, then the equation for line 1 would be y equals 1/3 or x over 3 plus 1. Okay, pretty simple. Okay, line number 2. So line number 2, let's put this in point slope form. So as I look at this, I need a point and I need a slope. So the point that I'm going to use is the point, let's go 0, 5. And the slope I'm going to use, if I look at this and I identify this other point, which would be 1, 0, I can find the slope, which would be y2 minus y1 over x2 minus x1. So the slope of this line is -5. Okay, and I'm able to use either the point 0, 5 or 1, 0. I'm going to choose to use 0, 5. I like to use the point where x equals 0. It makes everything kind of fall together very nicely. So I'm going to use the following form, and I'm going to use the point 0, 5. Okay, I'm going to plug 0 in for x and 5 for y. I'm going to solve for the equation of the line. Therefore, y minus 5 equals -5x. And therefore, adding 5 to both sides, I would get -5x plus 5. That would be the equation for the red line. Now, these are both acceptable forms, okay? So here would be the equation of the line in point slope. Here would be the equation of the line in slope intercept. If I decided to go one more step and put this into standard form, I could easily do that. I'm going to add 5x to both sides. And now I've got it in standard form, also called general form. Any one of those three would be acceptable and receive full credit on an assessment. Okay, our last slide for this lesson has to do with parallel and perpendicular slopes. So let's let y1 be a line that has a slope of m1 and a y-intercept of 0, b1, and y2 have a slope of m2 and a y-intercept of 0, b2. Now these are all general cases. We're going to get to numbers in just a moment, but the two lines are parallel. The symbol right here. Oops. Wow. What did I do? Okay, that was cool. This symbol right here, I know I want to use it correctly. There we go. This symbol right here represents parallel. The symbol right here, upside down T, represents perpendicular. Okay, the screen is like tilted. It's gonna bother me if that's the case. Okay, that's better. Good, cool. Okay, so what I want to do is I want to generalize how I know if two lines are parallel. Well, two lines are parallel if the slopes are equal. Okay, if the slopes are equal, I didn't mean to use yellow there. It came kind of surprised me there. But if two lines' slopes are parallel or are equal, we're good. They're parallel. Now, perpendicular is slightly different, but if one of the slopes is equal to the opposite sine and the reciprocal of the other, then they're perpendicular. Here is an example of two slopes that would be perpendicular. 3/2 for the first slope and opposite, so we're going to change the sign and we're going to reciprocate the fraction, -2/3. Here's another one. How about the first one is 0.2. Okay, the second slope, in order for these to be perpendicular, I'm going to rewrite this as a fraction and then take the opposite sign and reciprocate the fraction. Those would be perpendicular. If the slopes are not equal and they're not opposite reciprocals, these are opposite reciprocals. So if they're not equal and they're not opposite reciprocals, they are neither. Okay, let's do a couple of examples, and then you'll have a chance to get off to doing some of your practice problems. Okay, so write the equation of the line satisfying the given conditions. Here's a point. We're going to use point slope form. Here's a point, 1 comma 7. And we want this equation, this line, to be parallel to this line. Well, I don't know the slope of the line in that form, so I'm going to subtract 3x, divide by 4. I want it to be parallel to this line, therefore I want the slopes to be the same. Okay, so if I want the slopes to be the same, then that means I want the slope, switch to your other pen, there we go, to be negative 3/4. And now we're back to a couple slides ago when we were writing this stuff in point slope form. Y minus 7 would equal negative 3/4 x minus 1. We're good right there. That's point slope form complete. Okay, let's go to part 2. This equation of this line is going to contain that point and be perpendicular to the line y equals negative 1. Okay, this is interesting because notice that this line here has a slope equal to 0. If I rewrote it like this, you would see it immediately. Okay, so if it has a slope of 0, it's horizontal, right? All right, this is very interesting. So this graph would look like this, where y equals negative 1 goes right here through negative 1. Okay, so there's the line y equals negative 1. Now, if I want a line to be perpendicular to that, I want it to be vertical. And understand that if I want it to be vertical, then the slope is undefined. So it's going to come in the form x equals some number. Now, if I want this vertical line to be in that form, x equals a number, and I want it to go through the point T, then that means x has to equal 5. That's a really good question. But the opposite reciprocal of negative 1, in this case, is undefined. Very good question, and a good property to be aware of. This is our equation. And this is not in slope-intercept form, but that is the equation of the line. Okay, let's do the third one, and you'll be done for the day for this video. This equation is going to contain the point W, which is 2, negative 7, and be parallel to x equals 5. Okay, so if x equals 5, again, this is very similar to the question we just did in part 2. But if x equals 5, this is a vertical line. X equals 5. That's a vertical line. So its slope is undefined. So if I want another line that contains W, I want it also to be in that form. And therefore, x would have to equal 2. Notice W has an x value of 2. Therefore, if it's parallel, notice these two lines will be parallel. That's the symbol for parallel. You might remember it from geometry. It's got to have an undefined slope. Okay, guys, that's 1A on lines. Let me know if you got any questions. I'd be more than willing to help. Have a great day.